Hello, welcome to Chapter 1, Preliminaries. In this chapter, we will discuss fundamental mathematics terminology. Some of the important topics that we will cover in this chapter are as follows. We will talk about Taylor expansion. We will talk about orders of convergence, random variables and expectation, and we will talk about computer arithmetic, loss of significance, rounding errors, and so on. Let's start with the Taylor expansion. Here's the Taylor's theorem with Lagrangian remainder. Notice that here we have a function f, which is continuously n times differentiable on the interval a to b. And if also n plus 1th derivative of this function exists on the interval a to b, then for any point c and x in the closed interval ab, we can represent our function f of x in terms of this summation with n plus 1 terms, plus we have the remainder denoted by e sub n, and this e sub n is basically represented in terms of the n plus 1th derivative evaluated at some point psi, which is either in the c to x interval or within the x to c interval. So in most of our course, we will often refer to Taylor's theorem, and that will be important for us to be able to use this theorem with different type of functions. Basically, if you evaluate your derivatives at the point c equals to 0, notice that this x minus c becomes just x, and we have the k factorial here. So this is the special case of the Taylor expansion, and this is called as the Maclaurin Series. And you can also notice again we have the remainder here denoted in terms of the n plus 1th derivative of this function at some point psi. So let's do an example here. Consider the function sine x and try to write the Taylor expansion for this function. How you start to handle this problem? First, you need to start taking the derivatives. Take the first derivative, write it down, cosine x. Write the second order derivative, which is minus sine x, as we know from calc. The third order derivative, minus cosine x. Fourth, you have sine x. And you can see the pattern now. You can continue to write a few more if you like, but you can notice that for the odd powers of this derivative, we have the cosine terms, and for the even numbers of differentiation, we have the sine terms with alternating plus, minus, minus, plus signs. So how can we represent an odd number? We can represent it by 2k plus 1, and from k equals to 0 to 1 to it's going increasing. So these are the odd numbers, and for the even numbers you can use 2 times k, where these k are the integer values. So for these you can see that we have the cosine as the common term, and then we have alternating signs. Suppose k equals to 0, this is the first derivative, so this is going to be 1 cosine x. For the k equals to 1, what you get is the third derivative, so you can see it should be a minus 1, which matches with what we have written here. So you can also verify this similarly for the even powers of this differentiation. And when you combine these, notice that I want to evaluate this at 0. So remember, cosine of 0 equals to 1 and sine of 0 equals to 0. Therefore, in our summation, only the cosine terms will survive, and you can see that we only have the odd powers here, and you have the odd factorial and minus 1 to the power k as the alternating plus or minus sign. So this is how we can write down our sine of x using the Taylor series.